Hey, hey guys, it's Tuesday, March 31st, almost the middle of our third week. Today we're going to be working on solving exponential equations. Yesterday we did logarithmic equations, and today we're doing its inverse, the exponential version. You will definitely need a calculator today. I have the TI-36X Pro, and I'll show you how to use that. I don't have a graphing calculator here with me at home, but I will show you how to use that. If you have most of the graphing calculators will do what we want them to do. If you have an older version, you'll probably just want to contact me, find out how exactly to use your calculator. But these definitely are going to be problems where we're going to need our calculator, so make sure you have one that you can use. All right. A few days ago, when Miss McKibben was working with you guys, she should have shown you how to do some change of base. This is where our calculator is going to come in. So what I'm going to do is just show you real quick this problem here, this log base 5 of 15. And even if Miss McKibben didn't show you, it's okay. It's no problem. This is where our calculator is really going to come in handy. So what this says that we can do is that we can rewrite it like this so that we can divide. Okay, and so for those of you that have an older version calculator, you would have to do, this is called change of base formula. But when we have our newer calculators, this is how, let me show you how to do it in the graphing calculator, then I'll show you how to do it with the TI-36X Pro. So in most graphing calculators, if you hit this keystroke, the math button, and then hit up 3 times, the arrow up button, you'll run into this letter A right here called log base. Okay, so you hit the math button, hit up 3 times, and you'll come up with this log base. When you select log base, it looks like this. And what it does is it allows you to put your numbers as a base and as the number that's being logged. And so this first problem, log base 515, I typed it in, log base 5 here. So when you're moving back and forth using your cursor, it'll allow you to come over here and put a 5, and then you put your 15 in. And you hit enter, and it comes up with 1.682606194. Okay, so that's the calculation. Now back here on page 16, it says to round to 3 decimal places. So anytime we're using our calculator to come up with these answers, we want to round to 3 decimal places. And so you'll see me doing that. So rounding this 1.6826, the 6 rounds to 2, so our answer would be 1.683. Now let me show you how to do that in the TI-36X Pro calculator. Let me turn it on, and I will zoom this in so you can see it. Speed it up. Okay, so again, our goal is this log base 515. So the ln, that's the natural log. We'll talk a little bit about that today. And the log, the log. If you hit this button once, you get the natural log. If you hit that button again, it gives you the log, the regular base 10 logarithm. And if you hit it a third time, it gives you that log base option. So once again, if you hit this button 3 times, this natural log and log button 3 times, 1, 2, 3, it gives you the opportunity to type 5 in as the base and 15 as the number that's being logged. And then we get the 1.682, same number. So the 6 rounds the 2 to a 3, and we get the same answer that we were seeing over here, the 1.683. Okay? So whether you're using a graphing calculator or the TI-36X Pro, Both of the calculators will do it. And if you have questions about your particular calculator, please feel free to send me an email, send me a remind. If we need to get on Zoom and show you how to do it, we'll do that. Okay? All right, so without further ado, let's start solving some equations. So that's the lesson for the calculator right there. All right, so this should be page 16 in the packet. And so we'll just start off with this 7 to the x equals 20. Now please remember that is not multiplication, that is a 7 with an exponent of an x. Okay, so please make sure that you understand that is not multiplication, so we cannot cancel using division. You're not allowed to divide this problem. When I first got on with you guys today, I mentioned inverses. Well, what cancels an exponential? A logarithmic does. Okay, so what I'm going to do is I'm just going to rewrite this problem with a little bit more space. Sorry. Okay, a little bit more space. Zoom this out a little bit. All right, and so what cancels an exponential? Well, a logarithm cancels an exponential, and a logarithm of the same base. So what we do to one side, you have to do to the other. You can choose any logarithm that you want. What you want to do is choose a logarithm with the same base as the exponential. That's what allows it to cancel out. This log base 7 and 7 cancel each other out. X drops down. We now go to our calculator. We have to calculate. We'll calculate this log base 7 of 20, and that's going to be our answer. So 1, 2, 3, log base 7, 20, and you get 1.540 as that rounds. So 1.540 is how that rounds. The 5 rounds the 9, 9 rounds the 3, and you have to put a 0 here for the 9 because you have to have 3 decimal places. No need to check for extraneous solutions here. These are not logarithmic equations. These are exponential, and so anything will work. So that's our answer for that problem. Okay, just going to scoot this over a little bit so we can see. Okay, very, very similar problem to number 10. I'll rewrite that. What cancels a 4? What cancels an exponential? A logarithm cancels an exponential. We can use any logarithm that we want, but the one that cancels it is the one with the same base. So once we get this log base 4 and 4 together, they cancel each other out. X drops down. We make a calculation. 480, boom, 3.161. Okay, so that's the basic exponential equation. And so now we get into more like SADMAP type stuff where we've got multiple things that we have to worry about getting alone. All right, well, what happens if you have exponents on both sides? Well, that changes things quite a bit because now we're not using logarithms at all. We want to work on getting the same base. And so let's see if I have. I do not. Okay, so way back at the beginning of this unit, you had a chart of numbers, okay? And so we have to work on getting the 2 and the 8 to be the same number. And what you want to do is you want to make them smaller. So you want to work smaller. You don't want to work bigger, you want to work smaller. So the 2 that's sitting here, the 2, okay, we're going to leave that alone. This is going to be 2x plus 3. We're going to keep the equal sign. But the 8, right here, the 8 can be rewritten. Remember, you were supposed to have a pretty good feel for all those exponentials, like cubes and fourths and things like that. So this 8 is going to change to 2 to the 3rd power. So this 8, let's get a different color, 8 is going to turn into 2 to the 3rd. And then we have this exponent, 3x, that's still there. And now that we have these bases the same, the bases go away, and we have an equation, 2x plus 3 equals 3 times 3x is 9x, and you solve the basic equation. So let's see, subtract 2x, 3 equals 7x. We're going to end up with a fraction. Fractions are fine. It's not a problem. 3 over 7. Let me zoom this out. Just one more tap. There we go. All right, so over here, you have 27 and you have a 3. You want to work smaller. So the 3 is the base that you want. The 27, you want to turn into a 3. So we're going to go 3 to the 3rd because that's what 27 is. There was an existing exponent already there. That's the x. The 3 is the base. And the x plus 3 will remain. Okay, so what we're doing is we're changing the base number, 8 and 27, we're making them smaller. So we're making the base number smaller. So 8 is 2 to the 3rd power. 27 is 3 to the 3rd power. So we turn those into those values, and then we're able to basically ignore the bases and go straight to the exponents. 3x equals x plus 1. Take away the x. 2x equals 1. And this time x will be half. Okay? So those are the two main different types of equations. One where you have to use a logarithm, and one where you have to make the bases the same. And so when do you make the bases the same? When there's exponents on both sides of the equation. All right, let's just take a gander at a few more. Okay? So, do you have exponents on both sides? No, you don't. So here, we're going to use a log. Just to rewrite this a little bit bigger, 3x plus 1 equals 18. What kind of logarithm do we want? We want to use a log base 3 because that's what's going to cancel out the exponential. What you do to one side, you do to the other. We get this to cancel. X plus 1 equals, we have to make a calculation. Log base 3, 18. Whoops, hit the wrong button. It's 2.6301. Finish solving the equation. Subtract 1. X equals 1.631. Now, number 15 is a very tricky question. And you know, when you look at number 14, our goal was to get that little x right there by itself. Well, number 15 gets people every single time we show them because x is already by itself. So this is ready to be calculated. I get people trying to rewrite this when all you need to do is plug and chug. This is ready to plug and chug. So log base 7, throw a 9 in there. 1.129 equals x. Okay, it's tricky because you don't have to do anything, but it gets people all the time. So just be careful. Make sure you look. X is already by itself, so it's good to go. And we can move on. All right, moving on to page 17. So if you're following along, this is in the packet, page 17. Okay, now we have an E. Now, let's see, where can I put this? That's called natural log. And E, okay, are inverses. Okay, hopefully you remember that that means that they cancel. So we're going to do something very, very similar to these two problems, like we did to these two problems. We'll use the log, which cancels the base that we have. And in this case, since we have an E, it's natural log that's going to cancel the E. So let me rewrite this just a little bit. Okay, so that's just rewritten so I can write some more stuff around it. We can do anything we want to both sides of the equation. So we're going to use a logarithm that cancels what I have. That's what SADMAP's all about, is getting rid of things that exist. So these two things are going to cancel each other out. I'm left with 5k on the right. We'll grab our calculator. Right here, the natural log is the first tap. So when you hit your calculator for the first time on this TI-36X Pro, the natural log is what pops onto the screen. We're going to use 2 since we're calculating natural log 2. We'll hit enter. That gives me 0.693. We'll continue to solve the equation. Divide by 5. We're going to get an even smaller decimal. Divide by 5. And you get that right there as your answer. Round it to 3 decimal places. 0.139 equals the K. Again, no need to worry about extraneous values. There are no extraneous values in exponential equations. So no worries about that. Okay, very similar problem here for 21. Okay, what is it that cancels an E? Remember, our goal is to get X by itself. So we want this 6, we want this E, we want all this stuff to go away. Well, what's first? The E is. So we got to get rid of the E. We'll use a natural log because that's what cancels an E. Natural log both sides. Get cancellation right there. The 6x is what's remained, so it just drops down right there. We find our calculator. We calculate the natural log of 65. That is 4.174, which we will divide by 6. And get 0.696, 3 decimal rounding. Now we do have a mock quiz coming up this Friday, so I want to make sure everybody's reminded of that. It's on the blog, and we'll do it just like we did last time. You'll have from 11 a.m. to 7 p.m. to turn it in. All right, so now we're back to SADMAP, where we've got a bunch of different stuff on each side of the equation. And you just look at this. Is there any addition, subtraction we can do? Yes, the 3. We can add the 3 to both sides. 2e, which is multiplication. 2 minus 3x, which is an exponent. That's going to equal 11 plus 3, 14. All right, so that was subtraction, addition. Is there any division, multiplication? Yes. Let's divide by 2. E to the 2 minus 3x equals 7. How do you get rid of the e? We natural log both sides. Two minus 3x equals, time for the calculator, can't do this in my head, the natural log of 7. 1.946. Now, as I calculated, I'm just going to leave all that in the calculator. I'm not actually going to retype 1.946. Keep solving, so we'll subtract 2. Minus 2. Negative 3x equals negative 0.054. We'll do one more. Divide by negative 3. Scoop that up. That's a lot of problem. Just keep that calculator close by. Divide by negative 3. And we get our final answer, x equals 0.018. Okay, last problem. SADMAP. Is there any addition, subtraction we can do? No. So we move on to division, multiplication. What can we divide by? We can divide by 1,000. E to the 33x equals 9. Get rid of the e, use this natural log. So the calculator comes in. 33x equals the natural log of 9. 2.197. Divide by 33. Going to get a very small decimal. It's okay. Just let the calculator do the work. X equals 0. Some of y'all aren't going to like this answer. 0.0. Oh, that's okay. 67. Okay. So, couple things there. That finishes us off, but let's talk about a couple things before I set you free. One, you're gonna need a calculator, okay? Number two, learn how to get this into your calculator, okay? This is called change of base formula. You can do it this way. You can round, make sure you round everything to 3 decimal places. There's the TI-36X Pro, which is using the natural log button 3 times. There is the graphing calculator, math, up arrow, up arrow, up arrow, gets you to log base, which is right here. Choose the log base. It will show up like this, and then you can type in the 5 and the 15. Gives you the 1.68 answer, which you would round to 1.683. Okay? And then, finally, the natural log and e are inverses of one another. So make sure, if you see one of these, that you use the other one to cancel it out. Okay? And don't forget to use SADMAP. So, in conclusion, you got a Delta Math assignment. Should be open up by now. We have a mock quiz on Friday. It'll open up at 11 a.m., close at 7 p.m., just like we did for our mock test. please ask me questions. Okay, if you have a calculator that doesn't do the log base as I was showing you, please feel free to reach out to me and I'll let you know how to fix that. Y'all have a great day. Good luck.